Okay, so for these three FRQs, you will need your calculator. These are known as accumulation FRQs, and we're dealing with mins and maxes, and you're given rates, and you'll be using either the extreme value theorem or the EVT, where you had to create the table, and you'll be comparing. So what we're going to take a look at first is the actual question. So this is FRQ number 1 that was sent to you and is also posted on Blackboard. So fish enter a lake at a rate that is modeled by the given function e, and they give you the function here. So if this is a rate, that means that this is a derivative. And the fish leave the lake at the rate that's modeled by the function labeled L of t. So both E of t and L of t are measured in fish per hour, so it gives you the units, and they're saying that the time is measured in hours since midnight. So they're saying that the starting time is going to be equal to 0, and that relates to midnight. So the first question is, how many fish enter the lake over the 5-hour period from midnight to 5 a.m., and they want us to give our answer to the nearest whole number. So they're just looking at how many fish are entering. So what I'm going to do in my calculator is put this function in y sub 1, and I will go ahead and put this function in y sub 2. So you need to go ahead and do that first so that we can answer question A. So they want to know how many fish will enter the lake over this 5-hour period, and if this is the rate, that means we need to integrate from time 0 to time 5, and because my rate of entering is already provided that function, I'm just going to write here E of t dt. So I'm going to go into the calculator and put these functions in. So I put the two functions in here. This is in y sub 1 and I just typed it, and this is in y sub 2. This is the rate that they're leaving. Okay, so that way I can go into the home screen, and I know that this function is put in y sub 1. That's just for me. So then I'll go into alpha window, option number 4, and we want to go from time 0 to time 5. And I'm going to go in and I'm grabbing y sub 1 because this is the function that relates to the number of fish that are entering, dx. Okay, so I don't have to show any of the math. The calculator is doing everything for me, and this would actually be 153 fish. So this is equal to 153 fish. Okay, so I showed my work, I showed the setup, and this is the expectation that when you do this, you need to make sure that you show your work. So it's the answer for A. So let's take a look at B. What is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5? Okay, so first of all, average value is not something that you'll be tested on because it came from Unit 6, but it's still good practice. So remember, it's for average value, it's 1 over b minus a times the integral from a to b of f of x dx. And this is just in general. So this is your lower bound, this is your upper bound. And since we're going from midnight to 5 a.m., we can actually set this up. And since we're talking about the number of fish that are leaving, I'm now going to use L of t. So when I set this up for b, it's 1 over 5 minus 0 times the integral from 0 to 5 of L of t dt. Okay, so we're looking at the average number of fish. So this is going to be in fish because we're integrating, because this is the number of fish per hour that are leaving. So when I go into the calculator, I will type in exactly what I see here, but remember I put this in y sub 2. So what I have here is my fraction of 1 over 5, okay, times the integral from 0 to 5, and then my function is in y sub 2. And this is dx. So when I press enter, it says nothing about the number, like the nearest whole number, so I'll take it out, probably truncate at 4. So this would be 6.0590 fish, because it's the average number of fish that are leaving. Okay? Okay, so now we're going to take a look at C. And it says here that at what time over the given time interval from 0 to 8, so this would be midnight to 8 a.m., I guess, is the greatest number of fish in the lake, and we want to justify our answer. So what we're looking at is the number of fish that are entering versus the number of fish that are leaving, and this greatest number of fish is going to actually refer to the extreme value theorem. So when we had something like that, we wanted to look at, we used a truth table. We're looking at our endpoints, okay, and then we're also going to look to see if we're looking at the greatest number of fish, a maximum. If we have a maximum, so we're going to have to graph this. But what are we graphing? What we're looking at is how many fish are actually in the lake. So what's happening is over this time period, there are fish entering and fish leaving. So we will have a specific number of fish, or the rate at which they are entering and leaving, so we would have to integrate. So what we really have is a number of fish that are entering minus the number of fish that are leaving. Okay, this is entering that are leaving, and this is going to be the total number of fish over that time period. So this is the total that are actually going to be in this lake. So remember, this is because you're taking a derivative minus a derivative. This is still a derivative. So if we are integrating this, we've got the integral from 0, which is the beginning, to 0 of t dt. And we're looking to see what this value is. Well, remember, this is the same thing if you go back to your integrals from a to a, or from 1 to 1, 0 to 0, this means that there are no fish in there. I know that's typically not what's going to happen in a lake, but there's 0 fish. Okay, so then what we have to figure out is how many fish are in at this endpoint. So again, we're going to have the integral from 0 to 8 of t dt. And what t of t is this is in y sub 1 and this is in y sub 2. So I need to go into my calculator, go into y equals, and I actually unhighlight this and unhighlight this, and I'm going to take this minus this in my calculator, which is what I did here. So this is the number of fish that are entering minus the number of fish that are leaving. So what I want to do in my home screen is integrate from time 0 to time 8 to figure out how many fish are going to be in the lake at 8 a.m. So I need to go in and I need to grab y sub 3, which is right here, dx. Okay, so because it doesn't tell me to round to the nearest fish, I'm actually going to take this out. So this means I have, at 8 a.m., 80.9199 fish. Now what I need to figure out is there a max somewhere? So remember when you graph a derivative, when we did this on the number line like this, if we were looking at critical numbers, so here we have 0, here we have 8. If we have a critical number somewhere here in between, if the graph of the derivative is above the x-axis, that means the original function is increasing, meaning it's going like this. And then if the graph is below the x-axis, after that critical number, that means the original function is decreasing, so I would have a relative max here. Okay, so these two are the endpoints, and you're looking to see if you have a relative max. And the reason that I know it's a max is because it says the greatest number. If this said the least number, I'd be looking for a minimum. So what I need to do is I actually need to graph this function. So I'm graphing this, which is in y sub 3. Okay, I need to go into my settings. So first of all, my x-axis right now is going from -10 to 10. They're talking about from time 0 to 8. So I'm going to change this from 0 to 8. And it doesn't matter that the scale is 1. This, for my y value, is -10 to 10. I don't think that really matters, but I'm actually going to shrink my window because this is a little bit smaller. This might not be right. If it isn't right, I go back and fix it. It's not a big deal. But I'm just shrinking my window just a little bit. So now I'm going to graph this, and it might take a minute, but what I'm looking at is there a place where my graph of the derivative crosses the x-axis going from above to below? So what I actually have here, remember this is the derivative graph, so this is what I talked about right here. If this is the derivative, so this is, we'll just call this f prime, so you know I'm talking about a derivative. we're looking at where this graph crosses from above to below, and this is what I have right here. So there's a couple ways that you can actually calculate that value, but what I did was I actually put y is equal to 0 into my calculator, and it just traces over the x-axis. So now what I can do in my graph is calculate the point of intersection. So if I press 5, I just need to press enter, enter, enter. It's going to calculate what this value is. So I have a relative max at 6.20356. I'm going to go out kind of far here because if you recall from some of the previous FRQs, the further out you go, the more accurate you are. So this is actually a relative max. And remember, these two are my endpoints. Okay, so this is what we're testing. So I obtained this value, meaning the number of fish, by taking the integral from 0 to 0. Here I obtained the number of fish that are actually in the lake at 8 a.m. So now I need to figure out how many fish are in the lake from time 0, which is midnight, to whatever 6.20356 would be, whatever time that is. Okay, so I'm going to go into the home screen. And remember, t of t dt, which is how we labeled it, doesn't really matter how you label it, is in y sub 3. So I'm actually going to go in here, go into alpha window, option 4. I'm going from 0 to 6.20356. I'm grabbing y sub 3 dx. So the question here is, after all this work, what am I looking for? What is the greatest number of fish in the lake? So it looks like at this time, 1350149. This is the number of fish. So it looks like at whatever this time is. So it says at what time. So you would say the greatest number of fish in the lake occurs at time t equals 6.20356. This is your justification. They're going to look for that table. Okay, so justify your answer. Boom, it's right here. I did all the work. Okay, so that's for part C. The last part here says, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? Okay, the rate in the change of the number of fish. So first of all, this has to do with the derivative. So if we're looking at increasing or decreasing, we're looking to see, is the derivative positive or is the derivative negative, because it tells us about the original or the amount of fish. So they want to know, is the rate of change of the number of fish in the lake increasing or decreasing at 5 a.m.? So what we're looking at here in part D is t of 5 greater than 0, or is t of 5 less than 0? So t of 5 consists of the number of fish entering minus the number of fish leaving. So what I need to do is go into y equals, make sure that this is highlighted, which is the number of fish entering minus the number of fish leaving. And if I go into the table and I take a look at time 5, I don't care what the value is, I care if it's positive or negative. So what I would say is that at t of 5, this is equal to 17.8431, which is greater than 0. Therefore, the rate of change of the number of fish is increasing. This is the explanation for my answer. Okay, and you could also say that t of t is equal to the number of fish entering minus the number of fish leaving. This might actually help your explanation.